All right, welcome. So let's talk about what we're going to be doing today. I'm going to go over the homework answer. So the homework was to make canon kind of stimuli. It's kind of relevant to Pong because in Pong, your ball that you're moving around, you kind of have to have a better idea how to control that thing with varying speeds. And so the homework was intended to kind of show you how you can actually manipulate things like a ball with user input. Today we're going to be going over more things related to Pong. So I'm going to be talking about how to manipulate paddles today, moving them, as well as beginning the work of thinking about collision detection with paddles and how you actually do collision detection against rectangles with either a circle or another rectangle. And so we'll be going over that today. So let me start off with the homework. So the homework was to make a cannon that fires with varying degrees of strength based on the button you press. The goal was that it starts in the lower left corner and moves up and to the right when you press space, making sure this ball falls with gravity from lab number 2. And then setting up the keys 1 through 4 to launch the ball with varying speeds. So every key that you press launches it at a different speed. And then finally, changing it so spacebar fires the ball when you release it. So that when you are holding down the spacebar, it fires the cannon. It fires the cannonball out of the cannon faster the longer you've held it. So let's go over the first part, which is to have a ball. So starting with kind of an empty SFML project, I have this green ball, which I'll be using. And I'm going to make it be in the lower left. So I want this thing to kind of be in the lower left corner. Like so. And the first thing I want to do is just make the ball move up and to the right when pressing space. Now, as I've talked about this before, I kind of think it's important to approach these kinds of problems like one small piece at a time. So without even worrying about how to make it go up and to the right when pressing space, I just want to make this thing go up and to the right normally. Now, I wasn't specific on the first part, like how fast it should go. I just wanted to go up and to the right. But I was specific on the part number 3 and how fast I wanted it to go. So this required you to use the concept of delta time to incorporate into your movement so that you could actually specify exactly how fast you want your ball to move. And always this starts with having a clock object, which will maintain our time, as well as delta time, which keeps track of how much time has passed between each frame. And the goal being that I'm going to move my shape. I'm going to move it 100 pixels to the right per second, and then let's do 100 pixels. So negative 100. And so by moving the shape by 100 pixels per second, I know that I can have this thing cross the screen in a specific amount of time. Like so. Up and to the right. Now, this exercise also had some parts in it where this speed here is actually speed per second in that direction. So remember last week we talked about how 100 pixels to the right and 100 pixels up is not actually 100 pixels diagonally. Like moving this way and this way, 100 here and 100 here. The ball here is actually moving at like 141 pixels per second. Because Pythagorean theorem that this side of the triangle is longer than the other two sides. So like, how do I get this thing to move at 100 pixels per second in a diagonal direction if I know that this angle is 45? SOHCAHTOA? Yeah, SOHCAHTOA, right? So what do I take to actually get the x and y component of this? If I know I want to move this instead of 141, if I want to move this at 100, what I do is if I know that my opposite here, and this is my adjacent, I know that if I want to get this value here, then if I take the cosine of 45, that's going to be equal to adjacent over hypotenuse. So if I just rewrite this out, so cosine of 45 degrees is equal to what my x value is. This is what I want to solve for over 100. So when I want to solve for x, I multiply both sides by 100, and that's my x value. So I can do this in the calculator. So I'm going to take the cosine of 45, that number, and I'm going to multiply it by 100 because I'm going to multiply both sides by 100. 100 times this. These cancel out, and I get 100 times that. So I get 70.171. So I know that's what I'm going to use here. And negative 70.71. This will make it move at 100 pixels per second to the top right. You can't really tell. I mean, it doesn't look that much different from the previous run, but you'll know that it's correct. There is a way you can do this also procedurally too, because you can't literally put in a value for every single angle that you want. We talked about that as well. So what I can do is, and I'll show you guys this a little bit, is why don't I make a variable here that's my angle of launch. I'll make this 45 degrees, and I'm going to call it angle in degrees. And then I'm going to make another variable that's called angle in radians. And this is going to be equal to the value of pi, which I'm going to just copy from here. Here's my value of pi. And I'm going to have a const float for pi equal to that huge number. So if I want to convert something, I can have something that says, let me convert from degrees to radians is equal to 360 degrees, 2 times pi divided by 360 degrees. This is how you convert from what is a circle here that has 0, 0, 90, 180, 270 into a circle that has 0, pi over 2, and then pi, and pi plus pi over 2. Okay. 3 pi over 2. So if you want to convert from this, which is degrees, your normal 360 degrees, into this consideration, because when you're using the sine and cosine functions inside the standard library, these require the degrees to be actually in radians instead. So your coordinate space is actually in radians. All right, so there's my degrees and radians converter. So this is just a value that I can multiply against anything in degrees to get radians instead. So I just take this 45 times degrees to radians. So just by multiplying this value by this, I get the angle in radians. So if I take 45 and I multiply by 2 pi divided by 360, I get my angle in radians. Once I have my angle in radians, I don't even need my angle in degrees here. And I can take this, and instead of typing in the value here, I get what I want to do is I want to have a float value for my speed, which this is just going to be 100 here. This is how fast I want to move in a direction. And then what I do is I can have an x component, which is equal to the cosine of the angle in radians times the speed. This right here is exactly the same formula that's here. Cosine of the angle is equal to x over 100, and multiplying both sides by 100 gets me my value in x. And then likewise, my value in y is equal to the sine of the angle. Okay. So from the lab, I talked about how, while this is my adjacent, I'm just going to, maybe I can do this. Okay. This is my adjacent. If I want to get the opposite side, this is going to be my y value. This is my x value. The sine of the angle is equal to the opposite over 100. Remember, 100 here is my hypotenuse of the triangle. This is actually the length I have. I know I want to move. I want to move 100 pixels per second. So then, to solve for this, I do the same thing. I multiply both sides by 100, and so I get this formula right here, sine of angle in radians. If I just put in 45 here, this is not correct because this is in degrees. These functions require you to have them in radians. So that's why I have this equation here. It's just 45, which is my degrees, times my conversion factor, which is 2 pi over 360. All right. So then, finally, now I can do this, x and y. And I get the same thing. However, now I can change my angle. So let's say I want to launch it at 10 degrees here. I just change that value, and I'll change the angle at which my ball is launched. It's at a 10-degree angle now. Okay? I know this is not really, I'm showing you more about what the homework is. This ball is still moving at 100 pixels per second. But the key is that it's moving at the same rate, no matter what direction it's going. If I want to move 89 degrees, so almost straight up, it's still moving at 100 pixels per second. It's moving at the same rate. Right? So it's actually moving very close. So you guys can see kind of like how the angle here is the only thing that's changing. The speed is not. Seems like a simple thing, right? I just want to specify the angle. But in order for you to calculate the x and the y component of those, it changes based on the angle that you specify. But the formula still works the same way. So if I were to draw this triangle, and instead of 45, I want this thing, let's just say, I have a really tiny triangle here. Like something like that, right? And so the angle here might be something like 10. My adjacent is still here. My opposite is still here. This is still 100 pixels per second. But my adjacent and opposite values are completely different. Like this, my y value is much smaller than my x value here. Like if I actually do this calculation, let's calculate what the opposite value is in the calculator. So if I take the sine of 10 degrees and I multiply it by 100, my y value here is only 17 now. So my y velocity component is only 17 pixels per second, whereas my x value component is 98. So 98 pixels per second in x and only 17 pixels per second in y. But that'll get me 100 in the direction I want to go at this angle. Okay. This is how you get something like shooting in asteroids, or like really in any top-down game. Really in any game, is you understand what the angle is that you want to fire at. Okay. Okay. So this is how I have the thing move at a specific rate. Any questions on that before I go on to the next part?
When I was trying to do the homework, when I ended up doing the sine and cosine thing, when I ran it, it would go down instead of up.
We'll see how I'm multiplying the y component by negative here to make it go up.
Okay.
Because the coordinate space here is in SFML, it's 0, and this is positive 512. So I'm having my ball go from 512 to 0. So even though this equation here is going to give me a positive value for y, it's the direction that it's going to give me the length of this vector, but I want to move it up, and in SFML, up, the top left corner is 0 and the bottom left corner is 512. So if you want to move, you have to transform that. So okay.
I was thinking I did something.
No. So next I want to have this thing move only when I press spacebar, right? Because right now it's moving all the time. And this is a lot like the example for hiding the rectangle. You can make a new variable. I'm going to call this thing should move instead of launch. And instead of moving this all the time, you can have should move be an if statement around the move function call. And then inside here, you can have a if statement inside your event loop that checks to see if your key code is spacebar and you press the key, you just set should move equal to true. Okay. This means that now this value starts off as false by default, and the ball just hangs out there. So the false by default up here, set it to true when you press the key, and there's an if statement wrapping around it. The loop is still running all the time. It's hitting this. If I put a breakpoint here, see the yellow arrow, it's here. It just is skipping over this every time. Like literally it's just saying, I don't need to do any of this. This thing is never true, right? So that's how you solve it. You hit spacebar, and now that value is suddenly true, and is always true, because nothing is changing it back to false. So now it's moving. And so that's how you get the ball to move when you press spacebar, right? Cool. All right, so the next part was to make sure that it falls with gravity. So gravity is just the concept of adjusting the speed of the ball every frame. The speed of the ball right now is a constant thing, and x and y are constant as well. So what I actually want to do here is I want to make sure that my my velocity here, my y component, is getting adjusted by gravity. This thing here represents how much I should be moving in y. If I make a new value, which is my acceleration, and make it something like, I don't know, 200, this means that I want to adjust this value by 200 pixels per second every second. So I'm just going to take my acceleration here. I'm just going to take y equal to acceleration times. That's all I'm going to do here. I'm going to take my y value. I'm going to add in this amount times delta time every frame. So it's my speed, which in this example was 17, is actually my speed here. Yeah, which is 17. I'm actually got to do this the other way. I'm going to make my speed here negative at first, instead of multiplying it here, because I want it to be negative. So I'm going to take my speed, which I figured out to be 17. I'm going to make it negative 17 instead. And I'm going to slowly add to it every frame. I'm going to slowly make that thing go from negative 17 to negative 16 to negative 15. It's going to eventually go to 0, so it's going to stop. And eventually it's going to go positive again. So the ball, while it's moving up a little bit, it's going to slow down, go to 0, and then go back down to here. This is the speed I'm adjusting, and that's what I'm adjusting right here. I'm taking my acceleration value, which is 200 per second, and adding it to the y component. So now, here's my ball. I'm going to also make sure this is inside my if statement, because if it's not inside my if statement, my velocity is getting adjusted, even though I'm not moving the ball. So what I should see here is the ball goes up and goes down ever so slightly. I want to see this thing actually fall a little bit faster, so or I want to see the ball moving a little faster, so I'm going to have the ball go faster and then be affected by acceleration. The acceleration here is kind of slow, so I can increase that as well, multiply that by 4, and there's my ball. Okay. So this is adjusting the speed of the ball. If I make my acceleration something negative, my ball, which was normally moving in a straight line, is going to go up. You guys can see that here. At 100 pixels per second for my speed, it actually goes up, kind of floats away, as if there was negative gravity, right? So gravity really is just a matter of adjusting the speed of the ball every frame. And so I'm adjusting the speed here, which is my y component, by adding acceleration to it every frame. All right. So I want to set up the keys to launch the ball with varying speeds. 1, 2, 3, 4 is going to adjust the speed, is going to launch the ball with different speeds. So here, really all I have to do is when I press the keys for those speeds, what is it? Numeral number 1, you have all these numpad 1s and as well as number 1s. You're also going to set should move. I'm sorry, should move is not going to be set. What you are going to adjust is the speed. And I'm going to set up 4 of these here. And you could do this using a switch statement as well if you want to. This can all be done with a switch statement. It's a little bit simpler that way. But I'm just going to do num1, num2, and num3. And since I have this speed as a variable, all I have to do is just change this. So 1200 pixels per second. So now my ball by default launches at 100. But if I restart it and press 1, 300. Oops, this is not correct either. So this is another example of this is a good example of like being careful about where you're setting your variables. So I'm setting my speed variable here, but where am I actually setting my x and y velocity? Right here, right? So even though my speed is set here, I'm doing my calculation for my x and y here. So what I want to do is make sure that I'm doing that calculation when I'm setting the speed or at the time that I hit the space bar, which is probably more appropriate. So here, there's my x and y. And my x and y variables, if I leave these declared in here, are not going to be accessible here. So I get a compiler error. So you need to make sure that when you declare your x and y variables, they're still living here. And they're going to be 0 by default, because you should always initialize your variables to something. Otherwise, you'll get really weird, undefined behavior when you're trying to use a variable that doesn't have a value assigned to it by default, just in case you end up using this variable outside of this. But now I've moved that assignment for speed, or for the x and y component, into my if statement for the spacebar, because that's after, usually I'll hit spacebar after I've pressed one of these keys. Okay, so press spacebar, there's my 100. Press 1 and then spacebar, there's 300. Press 2, spacebar, 600. And then press 3. There it goes. Okay. Questions before I move on? Setting the speed. Once you have a variable for that, it's rather straightforward to have the speed be adjusted by these 4 keys. Okay, yeah.
Can you do it as the switch?
Yes, I can show you with the switch. Okay, so you can do the switch right in here. So what you're switching on inside your parentheses is going to be the code. And inside the switch statement, you have multiple cases for each thing that you're comparing against. So instead of an if statement comparing the key code to the value, you're putting, you see how it's all the same here? See how each of these if statements has the same thing on the left side of the expression, event key code? I'm just taking this whole thing and I'm putting it up here instead, right? That's what I'm doing. I'm taking the left side of this if statement and I'm putting it inside inside the switch up here. I'm taking the right side of each of these expressions and I'm putting it on the right side of the case with a colon at the end of it. And I will put a break for each one. And then what I'm going to do is I'm going to make 4 of these. And it's going to be 1, 2, 3. Remember, the break is necessary because if you don't have the break, what it's actually going to do is going to run, if it is key 0, it's going to run every single one of these cases until it hits a break. It's going to automatically run every case, which is why the break is really important, because you only want it to do one of these. And in this case here, just going to set the speed, 300, 600, and 1200. So it's a lot like the if statement, but the only thing that you get to worry about here is what you want each key to be and what you want to do when you reach that, when you have that key pressed. Switches are nice because they are concise and they sometimes can be faster depending on how many you have. Like in the code, I mean, the runtime can be faster. But this way the switch works, if I press 2, so look at my yellow arrow here. I pressed the code for 2, look, the yellow arrow jumped down to here and is running that code, hits the brake, and then we'll exit the switch immediately. So it exited the switch, and then it went back to the top of this loop to see if there's any more events. Okay. So that switch statement is pretty nice for this. It's really nice and easy to use. Okay. All right, so we're going to change it. So spacebar now, you have to release the spacebar in order to have it fire the ball. Okay. So right now I press the spacebar and it fires the ball, right? Actually, that's an interesting thing that I just discovered. Every time I hit spacebar, makes the ball bounce. Releasing spacebar is actually another type of event. So you have a key pressed event, you actually have a key released event too. So the first step is I want to make this if statement only inside the release event. I'm going to keep this spacebar down event for now, but I'm not going to do anything with it. So I have this key released event type, which is another type of event that Windows can send you. And I have the same exact if statement I had before. But now I'm holding down spacebar, and now when I let go, it actually fires. So here, I'm holding down space and then let go, and then it fires. Okay. Now, once I have it so that pressing the spacebar doesn't actually fire it, but releasing it does, I want to write code so that the longer I hold the spacebar, the faster it fires. So this means that while I'm holding the spacebar button down, I want to be accumulating how strong I want this shot to be. So this requires us to kind of keep track of the strength of the shot. So I recommended in the homework that you print out the strength of the shot that you want to be. This means that you need a variable to keep track of the shot strength. Now, the shot strength here is actually our speed. So we can actually print out our speed if we want to as well, or we can have a separate variable for it. I'm going to show you first how to use just the speed variable, and then I'll have you guys, I'll show you how to use a separate variable to keep track of it. So if I press the space bar, I know that I want to start accumulating the speed. But really what I want to do is, as long as I'm holding down the space bar, my speed is going to be going up. So you know that there is a separate function, isKeyPressed, that you can put inside your main game loop here. And for instance, make sure I include okay. So I know that while I'm pressing spacebar, I can have it print something out to the screen up here, like so, and I let go of the spacebar, and then it stops printing. What if I just took my speed here and I just added, I don't know, 1 to it? This is not really great because it's going to add 1 every frame, but you guys are going to see what it looks like. And instead now I'm going to output the speed as long as I'm holding down the spacebar. So every time that you see this message print, it's actually going to be showing you the speed as well. So there's my speed. I'm adding it up, and it launches it. So if I just tap it now, it just goes a little bit based on the speed. Now, this number here really shouldn't just be a regular number. We can use delta time as well to control how fast our speed goes up. Like, let's say I want you to have to hold down the ball for 2 seconds before it reaches 1200 speed. What I want to do then is increase the speed by 600 per second. So that it takes 2 seconds to reach 1200 speed, pixels per second. So you can watch the value here. It's going to start at 100 and it's going to add, it's going to go up to 1300 after 2 seconds. So there's my 1300 speed. So by also using delta time for this speed value, you can control how fast it goes up and down. Okay. Any questions on that method? Let me show you another way you can do this. You can also keep track of how much time has passed between you pressing the spacebar and releasing the spacebar too. There is another way you can do this. You can say, hey, I can have a variable that says time spacebar held. And you can have another variable here that says is spacebar held. You can do this without using any of the event loop. You can use this without using the polling method. You can use the event loop as well. So when you have the key press event, this is just another way to do the same thing. You can set a variable saying, hey, spacebar is held. And then what you can do is you can say, hey, inside here, if your spacebar is held, what you can do is take your time spacebar is held and add the delta time to it too. And now, as long as the spacebar is held, you're keeping track of it here. Then when you finally release it, what you can do is instead of doing this, using the speed directly, you can adjust it first. You can take the time the spacebar has been held times 1200 and just make that the speed instead. So because you keep track of when that spacebar is held and you have an if statement inside your main loop that says once you've pressed it, you are starting to accumulate time. And then finally when you release it, you take that time, you capture it, and you multiply it by 1200 and you set that equal to your speed. You get the same result. And what now I can do is I can delete this code. And what I can do here is do a cout here. And I can also say, set this to false as well. Setting this value to false so it stops printing out after I'm done pressing the spacebar. So here I'm going to hold spacebar down. Oh my god. I'll hold spacebar down. And you're going to see a very similar kind of result, only this time it's keeping track of the time that's passed instead. So I'm keeping track of time, I let go, and it still fires it off. So that's another way you could do this, you can solve this problem. Those are two methods. This is not using the is key pressed event. This is me capturing when you've pressed and let go. I think this has a problem though, because I think if I hold down spacebar here and then click off and let go here, so now I'm actually not pressing spacebar here. And so see how my hands are off and it still thinks that the spacebar is held? That's because the event for releasing the spacebar didn't make it to my game because I had something else in focus. Now I have to press it again and now it'll fire it. So that's one of the downsides of this method, is that I can be holding spacebar down. If I switch to like Chrome or whatever and then let go here, you know, the app never actually got the message for it. So, all right. So that's how you do that homework. Two methods to do that. Okay.
Can you include both methods?
Sure. I will comment out. I'm going to comment out this part here, so it only does the one method. Actually, I'm going to comment out, I'll comment out this method. Otherwise, you're going to get double increases. But I will do this. All right. Okay, any final questions on this?